Flipped lesson 2.4, seismic waves. The learning goals are to distinguish between primary and secondary waves, to describe how earthquakes occur, to identify the focus, the epicenter of an earthquake. Your vocabulary words are seismic wave, epicenter, focus, faulting, seismogram, seismograph, and body wave. This is an image of the anatomy of an earthquake. An earthquake begins when there is a sudden movement along a fault. This line that I'm making is your fault line. Energy that is released from the earthquake travels in the form of seismic waves. So these things here would appear to be your seismic waves. Okay? The earthquakes occur when there is a sudden break in the fault, a sudden release of energy. And this usually happens when either side, either this side or this side of the fault line has a sudden movement. There are two types of seismic waves. The first is known as a body wave, which are examples of these are primary and secondary waves. The other type of seismic wave is known as a surface wave. The first type of body wave is a primary wave. It is known as a body wave because it can travel through solids and liquids. It travels through the body of the earth. It is a high frequency wave, which means it moves quickly. It travels through all materials, solids, liquids, and gases. It is a longitudinal wave, which means the movement of the wave, if the wave moves in this direction, wave direction, the movement of the materials, which are rocks, will move in this direction. Just like longitude, it moves side to side, okay? The motion usually appears like this when you're looking at specific diagrams. And the movement is like a slinky. So if you know what a slinky is, that is exactly the movement that a primary wave makes. These arrows here represent the movement of rock. Movement of rock. The next example of body waves is known as the secondary wave. The secondary wave is a low frequency wave, which means it travels at a slower speed. Okay? They're known as transverse waves, which means they twist back and forth in their movement, similar to a rope. Very slowly. And as they're traveling very slowly, they're moving the rock materials up or down or side to side. So if this arrow represents wave direction, WD, the material, these houses, would move up and down as the wave is traveling through the crust only. Secondary waves can only travel through solids. They cannot travel through liquids, so they will not be able to travel through the outer core. Surface waves are their own type of wave. They're different than body waves because they only move through crust, the Earth's crust. They cannot travel through liquids. Their motion is similar to that of a secondary wave. They are responsible for most of the damage that occurs on Earth's surface. Because they're moving through the crust, they are destroying properties, buildings, structures, roadways. Anything that has to do with the surface is being destroyed because of the surface wave. The surface wave travels at the slowest speed compared to the primary and secondary wave. If you look at this illustration here, you can tell how scientists were able to infer what kinds of zones were inside of the Earth based on what kinds of surface primary, secondary waves travel through it. So right here, you know that this is the mantle. This is your core. So inside of your core, you would only be able to find waves that can travel through solids. We do know that the outer core is liquid, so if you look in this section right here, you would only be able to find P waves because P waves are able to travel through all types of mediums. You will not find any secondary waves within this section right here because this part of the core is liquid, and only primary waves, P waves, can travel through liquid. An earthquake. So this is the fault line that exists between two plates or two large pieces of plates. It can be a plate made of continental crust or a plate made of oceanic crust, or either or. So this is a fault line right here. So there's a sudden movement between this and this that causes a release of energy, which are these waves right here, causes a release of energy within the Earth's crust. So what I highlighted in red represents your seismic waves. Okay? If you look at this point that I'm circling in red right in the center, that is called your focus. And your focus is simply the point in the crust where the faulting or movement between the plates has happened. So it's basically the origin, where the earthquake began. Okay? Your focus your epicenter, which is this part right here in purple, is exactly the point directly above the focus. So it's basically what we can see on the Earth's surface. So when we're trying to figure out the location of an earthquake, we usually try to find where the epicenter is. We don't really try to focus on the focus because it's underneath the surface. We try to find the epicenter. How are earthquakes measured? A seismograph is a tool used or device used that detects, measures, and records Earth's motions. So any kind of motion made by either a primary wave or a secondary wave is recorded by this device. A seismogram is a recording. It's a recording on paper by this device. So a seismogram usually looks like this. It records the P wave and the S wave arrival times at different areas around the world recorded at seismic stations. The recording of the arrival times of both the P wave and S wave can help scientists find the epicenter, or where the earthquake originated. This information is important to help us analyze the destruction and the locations most affected by particular earthquakes that are happening around the world. They cannot help us detect. There is no way to predict when earthquakes are occurring, but we can help to measure and record data created by these seismic waves.